timing was such that there is a different reason, different thing, and the strategy work, the compromise comes here. And that's the kind of thing that we can bring it up. So you had to do that. And I think I talked about this one. Basically, the graph shows the cost is low, average, high, need or performance low, average, high. You always want to have high performance with a low cost. But if it goes a low need or a little bit of average, then you are throwing away your money. And the opportunity to improve value comes in between. And that just, okay. Another example, quickly going through, here is a project where you have a big median. They were going to add a lane on both sides, widening it. And this is a 6-mile highway. On both sides, they have already done where they didn't have the big median, so they put a barrier of kind, and rather than open. In here, we have more room. We need only a 8-foot shoulder. We have a 21 feet shoulder. And the reason they want to match the adjacent corridor. By doing so, all the water has to be captured, and the draining the pavement costs 29% of the total cost. This is the average need and a high cost. And that's a 29% under the dependability. We said, okay, you don't need to do that. Why don't you do an open ditch and create the one? Suddenly, draining the pavement costs come down quite a bit. So this is the kind of comparisons you always want to do. This is kind of how do you really allocate the cost to the function in the function cost? You're looking at a 4-span bridge, which is right now, there's no bridge. They are on an existing grade, and there's a railroad crossing. That railroad crossing causes all kind of delay, so they want to build a bridge. So if you think about it, to reduce the conflict and reduce the travel time, we only need a bridge about this size. But the railroad has the right to reject. They said, we're going to have a future rail, so we want to accommodate the future needs, which is a satisfied stakeholder. So the bridge went from 40 feet or whatever to this height. Okay, now okay, I could have it. Why do I need it? I could have a concrete retaining wall, and that would be a 1-span, but the concrete retaining wall costs more than having an open abutment. So you just slope the wall to protect the roadway here. But what I colored here is all you need, but they made it even longer, which they don't need. That is reason is they want to have a wider visual. So it attracts stakeholder. They did that here. We showed the cost of each one. Do you really need to spend the money? Then we couldn't figure out why there is a span here. We found out if you make this as an embankment, it's like a dam. This is a very heavy flooding area. It will flood the upstream. This will act like a dam, so you need to open it up. Then we said, oh, why don't we have a series of culverts? And because of the 24 feet vertical one and go 4-to-1 slope, the cost of the culvert becomes higher than the bridge itself. So this is kind of justifying the function cost of that. So generally, just to give you an idea, whenever we have function, we put all the elements, and then we put all the functions, and we allocate the cost for each one of them to say how much for basic, how much for dependability. This is yesterday's session. And again, you saw that yesterday in the function cost, we always compare with the norm versus what we do. One of the questions yesterday, somebody asked, what is the ceiling of a ratio? And what you are seeing is, I have taken a lot of the VE studies here, and each one of them is a study project. You see the basic function, even though I said a norm is 20%, look at the variation. In one case, the basic function, very basic structure, half of the cost went to that, which is very unusual. But then you look at it in one place, there's no really need for this project, basically. They are doing it for other reason. they are making it to satisfy stakeholder because they have, the bridge doesn't look nice. So they, the community, maybe the governor was in the neighborhood living, whatever the reason I forgot, but what are the reason the cost went up. So same thing when you look at here, assured convenience, 7.5%, 4%, 35. So this kind of tells you that the value is really defined by the decision makers. And there may be a background. Here is a project where they say, I don't want to spend anything to attract, just to build the roadway, just, no trees, no grass, nothing, just do that, zero. Then another case, it may be closer to a museum or a tourist attraction, suddenly 25%. If I'm doing a bridge next to Disneyland, at Disney World, there'll be more on attract stakeholder. This kind of shows you the ratio is really can change as designed. Then if the client says this is high, then we come up with a way of redistributing all of them. So this is just a measurement. Okay. Now the next thing I wanted to, the conclusion is the value measured by, you take the total cost of the project and then divide that by cost of the basic and dependability function. That ratio tells you what your value is. Let us say that the cost of the project is 100%, basic and dependability, let us say 50%. So the ratio would be 2. Now, normally, if you spend all the money on basic and dependability, nothing on convenience, everything else, it'll be a 1, because total would be spent on that. Now, if I have a museum, that value measurement could be 3, 4, 5. So it kind of shows you where you are. This is on the customer model. But if you take the same thing in today, what I talked about, the strategic one, cost of the critical path, which is in the middle, and cost of the total should be the ratio, okay? So now I'm gonna show the last example and how this number changes. I got here 17 slides, but I'm not going to go through all of them because it's similar to what I had covered yesterday. But I wanted you to know, here is a bridge. This is not in order, so I'm going to jump over. There was a new bypass we're building, which had a major interchanges. And it also have a railroad crossing here. I'm only going to talk about this railroad bridge in my function cost. Okay, so this is a railroad bridge that when you see the railroad here is an interchange. There is a ramp coming in from a lower level upward, and there's a merging lane. So even though this has 2 lanes on either direction, there is a merging 3rd lane on the bridge and a merging 3rd lane on this. So instead of a 2-lane highway, because of these 2 ramp merging, the railroad is carrying a 3 lanes. Okay. So one other thing, we didn't do it. If I move this is all planning phase. If I move this interchange a little further, I can avoid the merger here and I can only do 2 lane. That's an idea that, like I said, this has a lot of ideas, but that's not what I'm going to talk about. This bridge is very long because they not only the crossing of the railroad, there is a stream which goes through this bridge, under this bridge. Also, there is a concern about flooding that can happen. So they kind of conservatively overdid that, and they put the bridge 1, 2, 3, 4, 5 span. And the middle span here is to maintain the railroad operation at the $2.28 million, which is basically cost of this portion of the bridge. Then to mitigate the floodplain, they used on both sides at a cost of 3.72. Then in order to support, you have to have this span. So that's the functions here. Then when you look at the cross section, accommodating that ramp, this is a 2 through lane. They're adding that merging lane at a cost of $2.4 million. Okay. So the cost of the bridge, again, I'm not going to go through the functions. You can see all the functions. Accommodate merging is all the time. is 2.4 million. Mitigate floodplain is 3.72. They are not in the critical path of maintaining the railroad operation. If I wanted to only maintain railroad operation, I could have a shorter, less number of span at a cost here. So if I take the total cost, it's about 11.75 million, 11.7 million. The cost of this is only 5.6. So the value measurement say it's a 2. Then he said, okay, we are going to regrade the floodplain so that it goes through the creek, not through this one. So I can only have one span for the railroad and the support. Now, I also moved the interchange away from it so that I don't need to add that third lane. So now the costs become 5.63 million. Now the 5.63, I'm not spending any money on non-critical functions. So I'm raising the beltway to maintain railroad operation and support the pavement. And that's all I'm trying to do. And I'm assisting the mitigation of the water, and that's a slight amount that I did not show of regrading and so forth. But here we took a value measurement of 2 to 1 is the absolute minimum. If you do below 1, you are doing a cost reduction. And for example, how does that happen? You could say, I'm going to reduce the length of the span. Okay, if you do that, there's a derailment, your structure would be affected. So that means anytime you are going below that 1, it's a cost reduction, not a value improvement. So that's just an example of a project that I like to show. Function analysis can be used to educate engineers. You remember that yesterday we were talking about, for the students to educate them. Let us say somebody is in the second year of engineering or whatever, they have never done any retaining wall design. So how do you really teach them what does a retaining wall do? So this one, when you look at it, it's more for that, but it's also could be used for other things. So let me go through that. Okay, we have a retaining wall, which is colored here. I'll come back. This is again a real job. It has a very porous granular, it had a very soft clay. So we had to remove the soil and have a porous granular backfill to minimize the settlement. That's an unsuitable material. We had to do that. So now, generally, what's the function of a retaining wall is it resists the force, receives the force, resists the force, prevent the overturning, and then distribute the force, okay? Okay, now, number one, here is a grade separation between here and here. This orange colored portion of the retaining wall will retain the soil. And also it receives the force. You can see the 1, 2, 3. It retained the soil between here and here, receive the force and resist force, but it's not stable. Now you're intercepting the drainage. So you have to have a drain water, having a pipe here, having an impervious fill, all those things, the functions are to drain water. That minimize settlement, you need to replace all the 5s. You have to make the footing wider to minimize settlement. And that's one of the function of the footing. And it's also, you're putting a weep hole. That's, we are putting in cold climate, in order to, we had to locate the footing 4 feet below for the frost action. Otherwise it will settle, freezing and thawing. So this part of the retaining wall is still to minimize settlement. Then to prevent overturning, 5, 6, 7, if I can go back to the previous slide, the footing has 3 functions. It distributes the force to a certain amount. Then in order to prevent overturning, you have to increase it. Then to minimize the settlement, to increase more. And that's what you really see here. Then distribute force, I got 5, 6, 7. 8 is to enhance appearance with the handrail. And 9 is generally to protect the property. And 10, you want to raise the parapet so that people don't fall through, protect pedestrians. When you do that, and then you have to have the reinforcing here to transfer the force from the wall to the footing. And then the function logic diagram will look the same. But you look at I colored green on drain water and minimize settlement. What does that really mean? The cost, same way like I explained before, the cost of the minimized settlement is 22%. It's a really high number. So if I can have a steel sheeting, the sheeting receives the force, resist the force, prevent the overturning, there's no settlement, but it may not look nice. Enhance appearance is a function missing. So now the function you don't have drain water because it just, you have openings in the one, and we avoid the settlement by doing this. Now the cost minimized settlement went to 0. Other costs will go, but this is, in order to make it look nicer, what used to be enhanced appearance of natural concrete, now you have to have a precast fascia to hide the sheeting, and that cost you 18%. So we moved the 56,000 eliminated and spent 36,000 to make it look nice. So it's another way of looking at it. The third would be, we don't care about the look, then that could be a very minimal painting. So that way you can see when you're designing it, you can look at all these things and say which way I'm going to design. Am I designing a concrete wall? I'm doing a masonry wall. I'm doing a steel sheeting. All of them you usually compare, say, well, this doesn't look nice, but the decision maker would appreciate more how much of the cost going to each one of those ones. And this is a kind of an example. So that's kind of conclude my talk on strategic way of defining the function, defining the objective, defining the function cost. And again, it's a bigger example you can even see better, but in 1 hour, that's the best I could do. Now I'll open it up for questions. I think that there's a question, is value engineering a function of construction economics, or they are different things? In a big umbrella, it is still part of the construction economics. But the economics by definition has 2 things: utilizing the resources to the satisfaction of the users. Because if you can think about it, do nothing would save you the money. But if do nothing is economically, you want to be the optimum, don't do the project. So the reason you're doing the project is to satisfy the users, owners, and stakeholders. So the balancing the 2 is what the value engineering really do. Okay. The next question, will there be any presentation regarding risk analysis and constraint condition regarding function evaluation? There's always a risk. And if you listen to my presentation yesterday, when we remove the foundation and come up with a new idea, there's always, anytime you are doing something new the very first time, there is a risk involved. But the evaluation is where, unfortunately, I only talk about function analysis of the VE process, job plan. But if you go into information phase, speculation, evaluation phase, in the evaluation, you always do balancing 3 things: performance, acceptance, and a cost. So when you do that, in the acceptance, constructability, construction time, construction difficulty will all be the evaluation criteria. We will evaluate them. And then how much importance either a contractor or the owner or both gives it will kind of do that. There is, like I said, it is the entire process is really, there's always a risk, even when you build a bridge. For example, if you build a roadway, there's lesser risk than if you build a bridge. When you build a bridge, if you do steel or concrete beams, it's a next level. But if you do a post-tensioning and pre-stressing, it's the next level. And if you have a segmental bridge with the segments, it's a higher risk. So there is a level of risk is there, but the VE process will identify that between the function analysis and also the evaluation phase. The question is, in my project, I do VE at 30% and 60% of design phase. Is it correct approach, or do you advise any better? There's no such thing as a right and wrong approach. Anytime you do that, you improve value. But you would be more effective if you do it at a planning phase. And the reason, I think I mentioned that yesterday also, there are two reasons. One is there is no returning back, tracking backward. Second thing is nothing is committed. When you have a 30% and 60%, whoever is the author of an idea is going to have a pride of authorship, because in their mind, if their design is changed for better, they feel like they have not done a job right, which is not true, but that's kind of roadblock. And can I do it? I have done it at 90%. I also did it during construction. Depending on if you can make the changes because of the situation changes, then it's not a designer's fault. Most of the time, the VE, if a designer made a mistake, you correct it, that's a peer review. That's not a value engineering. Value engineering is not to find somebody's mistake and correct it. That's not value engineering. Even though it may improve the value, but that's not the process. The process is to do it the same thing, same functions in an easier or better way. So to answer the question, you can do it at any time, but my advice would be the earlier, the better. But I had to tell you, in one project, we did it at 95%. All our ideas were rejected by the Boston authorities. And the reason is they have issues with the contract and construction time and so forth. However, that project is a mega project. It's about a 10-year project. They have phase 1, phase 2, phase 3. They took our ideas. When they did the next phase, they made that changes in the beginning. So even when you are being rejected, and most of the department take the good ideas and use it in the future. So that is the value also. So that's why I'm saying there is always, it's a better approach at any time, whether you have a short-term benefit or a long-term benefit. Okay, I'm going to read this one. Reviewing various function, dependability, etc. for any particular project, can we say that it is brainstorming trial and error methods, including experience gained on similar project, or is there solid guidance to work on every project different type? Always previous experience is always helps. And that's why you have the team of looking at it. The only difference is, and like I showed the retaining example, that somebody may come back and say, well, my experience is we should rise the sheeting and put a fascia. That's not really maybe in a neighborhood where they are very sensitive about the concrete facing and having formworks. And so there is no solid guideline to work on it. And I don't know whether you listened to the yesterday's one. I use the example, is drain water in a roadway, is it dependable or convenient, satisfy user or attract user? That's not fixed one to say drain water is always dependability, because if your roadway has 70 miles per hour, you may have a hydroplaning there, it's a safety issue, so then I put the drain water cost to the dependability. But if it is in a neighborhood with a lot of shopping, mostly I've seen a very high-end one where ladies come with high heel shoes. They don't want their shoes to be get wet. Now there is a convenient function. And if it's a remote place where not much traffic, but one house is there, they want to do this, and that satisfies a stakeholder. And if it is an amusement park or a Disney World kind of things, then it's attract stakeholders. So there is, to answer your question, there is no guideline. It's your experience, your perception of what you think is the value is. How many occasions your experience the cost of project got increased? Almost 30% of the time, the VE recommended cost increase. Because that remember that sidewalk function I showed, and there it was neutral, but there are times certain functions were never thought of. And you need to increase it. Example, we have a project where, this is basically risk, desire, and a cost increase. We have a project, we're almost done, and then we found out just before the bid, we usually talk to contractors who is not involved. We call a contractor from another state. What do you think of this and so forth? And they said, have you ever looked at the history of this area? We said, no. He said, well, go and dig the history of this one. And what happens is there is a series of birds. They migrate and stay in the month of April, and then they go down south. So you cannot do any construction disturbing them in the month of April. So that means the construction schedule has to be moved 1 month, and the winter came in, so it has to be a 1.5 year construction. So we had to say the cost has to go up to satisfy stakeholder to protect the migrating birds. So that's kind of an extreme simple example, but a lot of times they have the number of lanes are not enough, or in the buildings, we have looked at it where somebody forgot to look at the deeds in a survey. Normally this is a real project where you had to increase. The bridge at the building has to be set back 6 foot 6 inches from the right of way. That's the City of Chicago requirement. So we designed the building. The building was built below ground floor level. But when the ground level came, we got a lawsuit from somebody. They said they used to own that land. Their grandparents used to own the land. They had the deeds. 30 years ago, they put a special deed. The setback has to be 10 feet. Even though City of Chicago had changed, whoever transferred the property never negotiated change the deed. So they say stop the construction. So what we had to do would be to, above the ground, 50-story building had to be set on a series of girder. And that cost quite a bit of money, but that's a value we had to come up with because of, in that case, it's an error, but it's so, the error is found, then say, how do you solve the error? We came up with an idea of adding 6 more floors with a lightweight concrete and with additional cost, but we are able to proceed with the project. So to answer questions, we should not go into the VE with a mind that we're going to reduce the cost. Cost reduction can be done by a contractor with experience without thinking anything. But if you're going to do it with what the stakeholder want, now the team of contractor, the owner, and the designer have to get together. The teamwork is where the value would come, not individual.
So. Go ahead.
I got one more. Any case study from your experience where VE application made long-term revenue generating, which was not planned? I got to think a little bit. I think I do not have a long-term revenue generating, but I have the long-term maintenance reduction. That's basically a life cycle cost. You look at, whenever we look at a project, we look at 100 years life. In 100-year life, if you don't do certain things, you may occur costs in the 20 years, 30 years, 50 years, and so forth. And you can project it and bring it back. But that's not your question. I had to think about it, but I'm going to say it should be. And where, okay. What I could answer this, I'm kind of struggling a little bit. Bear with me if my answer, you're not happy with it. What we have done when you have a project where you have a lot of land not developed, and we create interchanges so that we can attract business. When the business comes in, the revenue comes in, property tax goes up, sales tax goes up to the revenue. So you could look at, if you have a land use, you could do that. Now, can you bear with, I don't know where I can find this one. That's why I said, yeah, I wasn't prepared to that. Blue Cross Blue Shield in Illinois had a plan to build a 30-story building. And when I'm done, if I can find that graphics, I can show, but I'm not sure what it is. They have 30-story, but that's the they want to employ their 4,000 people, which they need 30 floor. But then what they said was they are able to rent more because of the foundation is 80 feet below ground and so forth. So they designed the building for 60-story. We did a VE. We said, we're going to design a building for 60-story with the foundation and the columns. But we could only build a 30-story. Then 5 years later, to increase the revenue, we built 5 floors, then another 5 floors later. So in that case, our VE basically is to design the column below and the foundation to take a 60-story. But we only built 30, and then that was in the 80s. Now it is a 60-story building. So if, as you're looking at it, let me look whether I can find that. I could find it, Nebu, when I find it, I will email you that graphics so that you can look at that, you know, how we did it. It's 3 slides. I'll forward to you later. Because right, I don't want to feel like I'm making up things, but we did do it to increase the revenue, but it didn't.
No problem. We can share it with the person who has asked that concern. Tibu has some concern actually. Yeah, go ahead, Tibu.
Good evening, Muthiah sir. I'm just wondering on the VE's application functions you applied, especially on the conceptual stages of the project. The one you shown for the ditches in the median, no, for the bridges, that was during the.
Which one? Which?
Conceptual stage. So you have enough variants to work on to apply the VE methodology. But still, again, the other example which you put for the pedestrian walkway, which was 2 feet, you said that both ways were 2 feet, and due to industrialization, yeah, one side you can avoid the you can get rid of the 2 feet. Otherwise, senior citizens accommodated with the medical facility. You said that you increase it to 8 feet, right? 6 to 8 feet, and you applied the value engineering methodology on that particular project. My wonder is how the regulations, because of course there should have been a shoulder and pedestrian is part and parcel of any project, right? Contract, if any contract is there, it is an existing project, you applied the VE. So how you get your approvals through? Was it easy to get the regulation, especially it is in the US, I believe. So how the regulations supported your VE on that project?
Okay, generally both AASHTO and the local agencies have 6 foot as a minimum. They do not look at, they will give you a permit if it's a 6 feet.
Okay.
And which is the flaw of the regulation, but the regulation cannot be for a specific one, because if they made it 8 feet minimum, everywhere you had to have 8 feet. So that's where the regulations and specifications and code average may 1, but then the client has to come up with it. Suppose, let us say we built 6 feet, okay? Now, let us say somebody walked on the road and got hit by vehicle. I'm talking about US. In US, the lawyers can sue the designer for a negligence. So that's what that one. Now, when you said that one, I'm also going to take one step further in Chicago. When I talked about that high-rise building, I don't know, you might not have, it is before your lifetime probably. There was a major bombing happened in Oklahoma where a truck came in and parked next to the sidewalk with a bomb. And then they exploded, and the pressure, really didn't, the bomb pressure really collapsed the building. So when this building was done, I did a risk analysis of, pressure propagation of the building. then I said, okay, if you have 8 feet sidewalk, 10 feet sidewalk, and 12 feet, because there is room for that, the pressure changes. So in order to minimize the risk, a 12-foot sidewalk will only damage the first floor. The pressure diagram is such. So what we did was in the 60-story building, the first floor beams were designed to take the rest of the one. So here's no regulation, but that's a specific thing. That particular client wants it because some client would say, oh, what's the probability I'm going to have? Don't worry about it, kind of thing. So that client is very conservative. They asked me to do a risk analysis for that kind of situation. Now the simple solution is to widen the sidewalk. That's a value.
But you're compromising the left side carriageway, right? I believe it's the right side carriageway you're introducing the 8 feet or 6 feet for the senior citizen, but you're compromising the left side carriageway. There is no walkway.
Yeah.
It can be, so it can be in a future development. You are not allocating the value engineering methodology on that. No, it can be future developing that area.
No, we talked about it, and what happens is right now it's an industrial buildings. Okay, let's say it's going to be a residential in the future. The developer have to change the zoning. When they change the zoning, the city would say, you got to give me a 6 feet sidewalk property, and then you can build rest of them. So that did come up, and you have a good point, but I didn't want to go into all of that. But that
is compromised. Is compromised there.
Yeah, I'm with you because there is a possibility the industrial area may go resident, more population comes in, but they got to go through the zoning. When they go through the zoning, the developer, because they have to do more with different drainage, storm sewer, than the sidewalk and so forth. So that,
it will be difficult in Kerala to apply all this, no
basically in India, the rules are so strange, and they keep popping into this kind of stuff. So when you have more utility, still they won't let you violate certain certain so-called norms, bylaws, which doesn't make even sense. So that is
as-built is there now. When you construct a project, you have to look into the as-built. So you are having a constraint in the as-built itself. You have to refer the as-built, like in Panchayat or village in Kerala. You have to start the approval from that level. So the guy sitting there will not approve your. Maybe the higher ups may be recognizing the value engineering.
I agree.
That guy will not recognize it.
Right. I agree because I would say about 15 years ago in New Delhi, the central government had not a seminar, 1 week inviting people from all over the country to how to make changes to the standard. And I represented US, and I came, and exactly because we said ASTM, and I was also representing ASTM. ASTM standard is life is only 5 years. Okay. After 5 years, it has to be reballoted by the entire membership, and they can vote it down. So that means any code, anything is only life 5 years in the ASTM. And I remember somebody from Ministry of Transportation in New Delhi, they said, well, we got code that's 20-year-old. We haven't changed. So it's a small process, but I think there are things that you can do without violating, like in your case, let us say this example of the sidewalk, you may end up having a sidewalk on the other side also. It may increase the cost, which still have the value, but that's a compromise.
So it's a tricky way, it's getting a value engineering applied in a project is really luck. You can propose, but getting it all the way through approvals, it's really a luck.
But in a case like that, that's what I showed that retaining wall. You can do it in a planning phase using this method to come up with a good design without changes, and hopefully, they approve it because it's easier.
Conceptual phase, in the architectural phase, it's easier. Applying value engineering in the architectural phase or the structural design phase will be easier. But once it is rolled out for implementation, it's very difficult to implement.
But I had to tell you, I'm a big believer because when I built my house in 1989, I basically did, the value analysis where I increased quite a bit of area with a much less cost. So you could apply it on your regular life in purchasing a car or buying a house and anything.
Yeah.
Did I miss anything?
Thank you.
Does value engineering can be effective in projects where major design changes are happening in perspective of sales strategies? Yes. When we did value analysis, we designed a high-rise building for the same developer. One is a rental property, and the next one is a condominium to sell the flat. And when we did the VE, the lobby is totally different for the rental property versus the condo. So value engineering could be applied in the perspective of sales. Marketing is really an area where you really can put your effort in the planning phase. Like I said, when you're designing your lobby, designing your elevator, they're all sales strategy if you're selling the flats. So the answer is, it's a very good tool, effective more than we talked about doing for a government where you have all the regulations. In a private condominiums and so forth, the contractor and the developer, if they're one and the same, could apply it for a marketing and sales strategy. Is there any question that I missed?
One just about the question which you just addressed, right? How VE can be applied some projects which never completed on the planned time frame due to natural calamities.
It's two ways. One would be you kind of expect certain type, not an earthquake, but a flooding. I'm going to make a note to send you a couple of slides. Could you forward to everyone? I mean, it's
yeah, sure.
Okay, Pico. The first one I said about the, again, if you bear with me for 1 minute, see what I can find the slides that kind of give you a better.
Sure.
This is a big one, but I'm going to move the slides to that particular one where natural slideshow from beginning. See what you're looking at this, when we were designing this particular project, after design is done, we did a value engineering, value analysis. Part of the information phase is we looked at the last 10 years, this is over a river. We looked at the river, point of view, how this river behaves, okay? So then we adjusted our unit cost, knowing the contractor knows this one, he's gonna have a risk avoidance or risk mitigation cost. We included that cost in the project. So what you're looking at on the screen, you can see the screen, right?
Yes.
Okay. See, this is the way the contractor got his one. You know what happened in 24 hours? That's the way it looked. So we knew that it can be flooded, and we took a certain amount of thing in our designing our bridge. We have a longer span, so the river can flow much better. We also looked at it, the concrete can be poured with the water underneath and so forth, okay? But in the same thing, I think somebody asked me a question before about the bat. See, the April and July, not only the migrating bird, we cannot remove the trees in this one. So when we schedule it, in this value engineering, we did the value analysis of schedule only, not the cost. Just how do you, they said, can you build it in 1 year? We looked at all the constraints and looked at it why. And here, you cannot cut trees in that time. And when you're ready to cut the trees, it is flooded. So they had to use a boat to cut the trees. So the cost of removal tree went up quite a bit. And also this schedule moved up to a winter. So these are the natural, issues that we do look at in the VE, how to build a bridge. See, here's the bridge is ready to build. And day before, couldn't find it. But anyway, to kind of give you a point of value analysis could be used in different things. And we looked at a different span, and we said, okay, if I have a 90-foot span, cost is $80 square feet, 250, 105. The difference between the two is for the function minimize collection of debris. And then instead of 4 girder, in the future, they're going to do half-width construction of a deck. 4 girder system you cannot do because 2 girder is not done. So we had increased to 2 more girder. So $4 square foot would facilitate future deck replacement. So that's a function. So I'm glad I took this to show. Okay, thank you.
Thank you, sir.
Thank you.
Thank you so much.
Longer.
Yeah, well, I think we should call it a day. Sir also would have other programs. On behalf of IEA Kochi Local Center and Construction Philosophy, I would extend my sincere gratitude. And so we'll be very, very grateful to you for this whole information that you have given us. And to all the participants here, I would like to say that this is just a beginning of understanding a concept, a new concept, wherein we understand the functionality and we start analyzing the functionality of any aspects or any item of work included in a particular project. As we all are aware of, in Indian scenario, we are concerned about the cost, not the functionality always, most of the time. If you look at the infrastructure, the roads or buildings or condominiums or anything, if you take, mostly they are always concerned about the pricing, the costing, but less are they concerned about the functionality. And let this be a beginning for all of us. The 69 people who have registered with us for this particular program, let us start this practice of bringing value engineering forward as one of the major aspects of our design, our practice, our engineering profession. The rest of our career should be planned and designed according to the knowledge that we acquire from people like Professor Muthiah Kasi and the people that we are going to listen for the next couple of days. And that is the intent of construction philosophy's effort. And if that is done, then we are also happy, and we are successful in our mission. Thank you so much, Kashi sir. Thank you, and we're going to see you again and again, and we'll be very eager to hear from you again and again. Thank you, all the participants. Thank you so much. Good night to all. Good day, sir.
Good day. Thank you.